going to be discussing numbers 1 to 9 of basic acoustics. So our members are Deslate, Galios, Israel, Juanillo, Maniago, Medrano, Ngo, Temana, and Vergara. So moving on, these are the terms that we're going to be discussing. So the first is acoustics. So acoustics is the branch of physics that is concerned with the study of sound, particularly production, control, transmission, reception, and effects of sound. It can also refer to the effect a given environment has on sound. So it's not just like the production, control, transmission, reception effects on sound, but it can also refer to the effect of a particular environment. Let's say the environment is an open space compared to, let's say, an environment which is a closed space, let's say recording studio. So that has a different effect on the sound that you will be perceiving. So psychoacoustics is the study of the ear, brain, auditory system, and its perception and reaction to auditory stimuli. So the difference between acoustics and psychoacoustics is that psychoacoustics basically involves like psychology. We have here that psychoacoustics combines the study of acoustics and auditory physiology. So it has something to do with, let's say, the brain auditory system. So yeah, so basically that's it. Next is sound. Sound is the sensation produced by stimulation of the organs of hearing by a series of vibrations transmitted through the air or other medium, especially those within the range of frequency that can be perceived by the human ear. So basically, diba we discussed acoustics, which is the study of sound. Now, sound then is the focus of the study of acoustics. It says here that it is produced by stimulation of the organs of hearing. So sound can be perceived by our hearing, and sound propagation will be discussed later on. So we have sinusoidal motion. Sinusoidal motion is the movement of an object in simple harmonic motion, or any motion where a restoring force proportional to the displacement is applied. So here is an example of a sinusoidal motion. We can see here that the pattern looks as if like it repeats itself. That is why it says here that it's simple harmonic motion. So, yep. Then we have complex waves. Complex waves are waveforms consisting of a fundamental frequency with superimposed harmonics. So we have two complex waves. First is the longitudinal waves. So longitudinal waves wherein oscillations where the particular displacement is parallel to the direction of wave production. So as you can see from this GIF, we can see that its movement is in a parallel direction. Let's say, as you can see here, the oscillation is in a parallel direction. So the animation identifies the regions of compression and rarefaction. So compression is here, like how close it is, and then the rarefaction is basically like how molecules are far apart. So their direction is from left to right, as you can see. So here are like practical examples of longitudinal waves, those that come from like speakers. And this right here is the direction of the propagation. As you can see, there are no depiction of like waves. It's just on like a parallel motion. Next is the transverse waves. So oscillations where the particular displacement is perpendicular to the direction. So to the direction of wave propagation. So the animation below shows a one-dimensional transverse plane wave propagating from left to right. The particles do not move along the wave. So we cannot see the compression and rarefaction in here, but we do know, or we can observe that the particles are moving up and down, not left to right. So that's basically like the difference of the longitudinal and transverse waves. As we can see, this is moving up and down, while the longitudinal waves is moving from left to right. So here are the illustrations of the direction. This is the direction of propagation, where we could see here that the particle motion seems as if like it's, again, it's an up and down motion. And yeah. Okay, now moving on to spatial concepts relevant to acoustics. So spatial concepts, we're going to be talking about the relationship between us and objects, as well as the relationship of objects to each. So here are the terms. First is diffraction. It is when the sound waves bend as it moves past an obstacle or through a narrow opening. So we have an example here. Let's say there's a wide gap. So the diffraction, it doesn't bend that much, but let's say there is a narrow gap. So the diffraction effect is larger, okay? It bends a lot more compared to this one. So this is the obstacle here, the gap. Then for the refraction, it is when sound waves bend as they move through different media. So let's say the media is cool air. So the sound waves, they basically change or they bend. For here, the warm air, basically the sound waves go in a different direction. So if you're confused with the difference between diffraction and refraction, basically diffraction, as you can see, is the bend, literally the bending of waves around the obstacles, but refraction is the change in direction. See, this is the change in direction. As we can see here, the sound wave seems to move like upwards compared to the sound waves in the warm air, which seems to go like downwards. So that's basically the difference between the diffraction and refraction. So yeah. Next we have,
Hello, good afternoon. So now we'll be talking about reverberation. So it is the result of sound waves reflecting off many objects or surfaces in the environment. So reverberation is like the reflection of sound waves. When and partially reflected after it hits a wall. So it is a single reflection of a sound wave off of a distant surface, and it is usually clear. So comparing the two, ang echo is very clear, while reverberation is not. So there's like murag na two persons speaking at the same time sa reverberation. So next, please. Reflection is when reflected sound arrives to your ears after a direct sound has been made. It plays an important role for an individual. So for example, it is important because it is used to give feedback. For example, if you're gonna speak, so oh, this is how I sound through reflection. Diffusion is the even distribution of sound energy in a listening space. So once again, diffusion, so it is from a high to low concentration so that sound is evenly distributed. Next, please. Temporal concepts allow the understanding or recognition of auditory stimuli. The brain processes auditory stimuli and puts it in a context such as time, space, placement, and sequencing references. Temporal processing is important because there's always a definite change in one's environment. So we always have to adapt to our environment because there could be barriers or noises. So temporal processing also allows us to adjust or adapt to change. And it is hearing care professionals need to be familiar with this because sometimes children with auditory processing problems have difficulty in the temporal processing or of the auditory stimuli. So this can hinder their acquisitions of speech, language, and reading. However, older individuals could also have like temporal processing deficits, which can affect their ability to understand speech and benefit from amplification. So next. Sound propagation is a process where the energy of sound travels and not the particles of the medium. Compression is an area in a longitudinal wave where the molecules are close together and the air pressure is higher. However, rarefaction is an area in a longitudinal wave where the molecules are farther apart and the air pressure is lower. So compression occurs when the pressure is higher, and rarefaction occurs when the air pressure is lower. So this allows the compression and the spread out, which is rarefaction. Next, spectrum. It is a graphic representation of sound in terms of the amount of vibration at each individual frequency. It is in a graph of a spectrum, frequency is along the horizontal axis because it is an independent variable, while amplitude is along the vertical axis. So it is a dependent variable. There are two types of spectrum. One is line, and the other is the continuous spectrum. So the line spectrum displays the frequency content of periodic sounds, while continuous spectrum displays the frequency content of aperiodic sounds. So periodic, meaning to say it repeats at regular intervals, while you know naman na aperiodic does not. Next, please. So a spectrogram is a detailed picture of sound components or harmonics of formats. So essentially, a spectrogram is a picture of a sound. So components niya is frequency. It is shown in the ordinate or the vertical line, while time is shown in the abscissa rather, which is the horizontal line, while the intensity is based on the relative darkness of the image. As you can see, there's a gradient. So that's it. So thank you so much for listening.